Go music. Let's go random, loop. Okay, that shall be good. Let's check the volume on that. I like it a little louder. It's fine. I do want to open Twitch. I had Twitch open was a good thing. We got this over here. Okay. Oh yeah, cellophane. What up, dude? Okay. Ba-da-bum, ba-bum, ba-bum. Okay, let's grab this ray tracer challenge. So here's what happened. I had such a great time doing this ray tracer challenge because I feel like it kind of sharpened my coding skills. And it's a graphics project as well. So I'm going to continue to go through it. And I didn't even do that much preparation before I did the stream. You guys are like, we can tell. No. So I'm just going to dive right in because it's just totally step by step here. And I feel like I'm also learning as well, which is great. Instead of just going step by step and not learning, you see what I'm saying? So let's see, what do we got? There's the space trader. Let's shut that down. Ray tracing 001. Okay. So let's run it and see what we got again. Alright, so we have this. Position, magnitude, normal, gotcha. Okay. Yeah. So what do we do now? Okay, representing colors. Points and vectors, fundamental ray tracer. Let's just jump right in. Representing colors, gotcha. Okay, color operations, it says here. Okay, one way or another, you're going to need to be able to create a color from a red, green, blue tuple. Add the following test, which does just that. Colors are red, green, blue tuples. Given C color, in practice, you only use the number 0 to 1 for these components, but don't put any constraints on. Oh, so we're going to make a color. Oh. So how do we want to do that? See, we get the tuple, right? Position, magnitude, normal. All right. We've got the tuple. I don't know if should we make a whole separate other class for this color, or I don't really know yet. What are we doing with these colors? Adding colors, subtracting colors, multiplying color by a scalar, doing the same thing, creating a canvas. Okay. Hadamard product. Okay. The method of blending two colors works by multiplying corresponding components of each color to form a new color. It's technically called the Hadamard product, or Schur product. But it doesn't really matter what you call it. It just needs to produce a new color where the new red component is a product of the red components of the other colors, and so on for blue and green. Once those tests are passing, you're ready for the next step. Okay, so it's safe to say that colors are pretty much exactly what we have here. It's just that when you get the color, you're just going to get the RGB. For example, if I want to do tuple 6.position.r, it's a thing. G and B. See? So I think we're good. I don't really... There's nothing here that we haven't already tested. Because GLM already has it built in. So adding colors, subtracting, multiplying by a scalar, multiplying the colors. Let's do this. Multiply, I don't think we have. See, multiply by a scalar we have, but dot width, cross width, subtract, add. Okay, so we don't have like blend with. Let's make a function blend with. There we go, and it'll return a new color. Or should it morph the color? If we have a color and we blend it, that's a tough one. Let's just have it return for now. We'll have it return a tuple. We're going to call this one blend with. Okay, so whatever color it gets blended with, we're going to go like this. Return tuple. Okay. We're going to return a GLM vec4. In this case, we actually don't care about the I was about to say we don't care about the fourth component, but we actually do. We're going to make it 1 automatically. So let's go position.x times other.position.x, comma, position.y times other.position.y, position.z. And actually, since this is color, hold on, since this is color, we should be RGB, like that. Just for clarity in code. And then we're going to make it 1, which is fully transparent all the time. Optionally, we can send in a transparency. No, I think that we're just going to make it 1 for now. We will address the transparency at a later time. So if we have a color, and then we blend it with another color, we will get the multiplication of each component separately. Okay. That's the only thing that we don't do yet with tuples, so let's see what we got. So let's go up here. Where are we at? So we have this color. We're going to go 0.2, 0.4. We don't care about the 1. Make a tuple. Okay, then this one we're going to go 0.9. Okay, let's leave it at 0 just to test it. Okay, then we're just going to go down here. We don't need anything else that we have down here, by the way. There we go. See, I love this now, because now I know what just tuple1.show. I did some drinking last night. And the night before. This is my days off. Well, it's supposed to be. Yeah, it was a whole mix-up kind of a thing. I don't know what's going on with the schedule right now at work, but I was supposed to work today. I called out last night because I didn't discover that I was supposed to work until after I started drinking. And it was way too late. Then I was halfway in through a really strong beer, Goose Island Bourbon City Stout. If you don't know what that is, Google it. It's delicious. It is a dessert. Anyways, so so tuple is going to be, we need a blend result. And then when we do that, we need to go tuple1.blend with tuple2. So what that does is it takes tuple 1, blends it with tuple 2, and it returns the tuple, and then it creates blend result as the result. And then we're going to go blend result, show, and we'll see what we get. And it shows each one first. I think we can take out that, there's a thing, okay. Position, magnitude, normal, position, magnitude, normal, okay. And then this one, the position is 1 times 0.9, which is 0.9, 0.2 times 1, which is 0.2, 0.4 times 0.1, which is 0.04, and then that did it correct. Okay, so we're good. That is the test we did, and we're moving on. So that's the blend result right there. That works really well. And I even forgot to look. It should have been 1 as the last. Yeah, this component is 1, so that works fine. So it's 1 and 0, but it's not multiplying it, it's automatically making this 1. Okay. And in addition to this, can you do 2 STD and Ls like that? Yes, that looks better. That looks better. Perfect. Alright, and we have Twitch open. Is anyone there? Cool. I just didn't want to miss anybody. Okay. So now we have the canvas. Let's work on the canvas. So the reason I included the STB stuff is because a canvas is just a rectangular grid of pixels, much like your computer screen. Your implementation will allow its size to be configurable, so you can specify how wide and high the canvas ought to be. Add the following test to your suite. It demonstrates how a canvas is created and shows every pixel in the canvas should be initialized to black, color 000. Canvas, every color. Pixels are drawn to the canvas by specifying a position and a color. Write the following test, introducing a function called writePixelCanvas XY color and showing how it is used. So it will take a canvas. Oh, writing pixels to a canvas. Note that the X and Y parameters are assumed to be 0 based in this book. What does that mean? That is to say, oh, okay, it tells me. That is to say, X may be anywhere from 0 to width minus 1 inclusive, and Y may be anywhere from 0 to height minus 1 inclusive. You won't need any other methods for writing to your canvas, since your ray tracer will work pixel by pixel over the entire scene. Make those tests all pass, and then we can talk about how to save this canvas to a disk in a format that will actually be meaningful. I think we already have that too, so let's just do a canvas real quick. But I don't know if it'll be real quick, but let's, because what I do with the Space Trader here, I do screenshots, and I think I put that code into the main includes. Let me double check. Yes, okay, so that's not even here, sorry. It's in main includes. Do show space cleanup, fine. Okay, hold on. Take screenshot. There we go. I think that's where we need to go. So show me the definition. Go to definition. Oh, computer, no. What are you doing? Forbids macroizing? Okay, I learned a new word. I want to go to that definition. Okay, what was that? Watch out for that macroizing, everybody. Wow. Okay. Screenshot code, viewport, get integer GL viewport. Okay, I may have to take a break as well because I do need to make some soup, and I also need to clean up just a little bit. Don't know why Steam was running. Free up some memory there. What else? Not that I'm not loving the Stellaris, but can we go back to favorites here for a second? And there we go. Bum. What's XY? Read pixels, XY width height. What is that, the beginning? Interesting. So data equals char star appointed to an array of chars. Malloc. Allocate. Size t, width times height times 3 for RGB. So you notice transparency doesn't work there because transparency only affects the final color. It's only used in calculation. It's only used in calculations. So it's not actually physically part of the screen. It's just only used in calculations. If data pixel store I GL pack alignment read pixels Oh, I see. So this just, yeah, kind of tells you the format, GL pack alignment 1. Read pixels, GL RGB, GL unsigned byte data, and then it creates the file name. So what this does is it counts the number of files. And if the number of files in the directory is greater than 0, it takes this file name, and you see the 789? It takes the number of files in the directory, and it parses up to 1,000, up to 999. It parses the number of files, and it will change the file name, and then it will save the screenshot, tell you the file name that it changed it to, and then save it right here. STBI write PNG, file name, width, height, 3, data, 0, free data. So I did this because whenever you hit the screenshot, instead of prompting the user for a file name, which I could do now with IMGUI, I didn't when I had made this code, I used AI to do it, and I didn't know, I wasn't using IMGUI, so I didn't realize that I could use IMGUI, which is probably a better idea, but it's all good. But that's my screenshot code, and I've just reviewing it here to get it back into my brain, because it's been a while. So I wonder if this is the best way to just allocate the data. Let's go ask Bing real quick. Let's get a professional opinion. Just to see, in C++ with GLM using OpenGL, is this the best way to allocate memory for a canvas? Oh, we do that? Okay. If data equals null, I think we have that. Yeah, if data. So yeah, we don't do anything without checking that. So very good. If you switch to using new and delete the equivalent code to be char pointer data equals new char. Oh, that's cool. That looks cleaner. In both cases, remember to handle errors and free delete memory when you're done. Also, consider using smart pointers or container classes that automatically manage memory if you can. They can help prevent memory leaks. For example, you could use std vector char to hold your data. It will automatically deallocate the memory when it goes out of scope. This way you don't have to worry about calling delete or free. The vector will clean up automatically. Oh, and that creates it of that. You can get a pointer to the data with data.data. This is especially useful in real code where there may be many paths through the code and many places you need to clean up. It's easy to miss one with manual memory management. I think we should do that. I want to take note of both of those right now. So let's go into the ray tracing. Excuse me. Let's go to the bottom here. Excuse me. I know. What am I doing? I don't know. But I just want to keep that there. And then this right here, the vector is really... The vector is the cleanest way to go, it looks like. Because the vector takes care of allocation, takes care of cleanup when it goes out of scope. This is better. To me, this is better because it's also cleaner, but this is even cleaner. So I think we might go with creating a vector when we create a canvas, and it's got a width and height. I think that's all we need. Let me look. And then when we write to the canvas, we need a reference to the canvas, an XY position, and a color. Okay. So when we create a canvas, we're going to give it a width and a height. Let's do that. Let's just go with the vector. Save the comment in there too. So the canvas is going to be different now. See, we have the tuples, we have all that. Now we're going to do a canvas class. You don't say. Yes, I do say. All right, here we go. Class canvas. We're just going to put the vector in there. Boom, bada boom, bada bing. std vector. I think I have to include vector for that one. Right? I think that's what we have to do. And then width and height. Okay, so... So the... Okay, let's just... Can you help me fix and finish this code? It's like, oh boy. Yeah, oh yeah. Sure, I'd be happy to help. In your canvas class, you're trying to declare an std vector char member variable data with a size of width and height. However, your width and height are undefined. You might want to add width and height as member variables of the canvas class initialize data in the constructor. Here's an example. Okay. Width, height. Oh, I gotcha. Interesting. Private width, height, data. Oh, cool. In this code, width, height, and data are member variables of the canvas class. The constructor takes width and height as parameters and initializes the member variables. The data vector is initialized with the size of width, height times 3. This way, when you create a canvas object, you can specify the width and height, and the data vector will automatically be sized accordingly. That's perfect. Absolutely perfect. That is the only reason I question why people, I ask them if they're using AI and they're like, oh, I never can get it to work. Did you see the prompt that I gave it? Did you see this prompt? Okay, great, I've decided to go with the vector. Here's what I have so far, and it's complete garbage. But it can actually tell what I want to do. It fixes it, and it finishes it for me. And then there's an explanation. You see, this is just sharpening my skills. So it takes a width and a height. It puts those into the width and height variables. This is, yeah. I just want a quick explanation for this constructor. Can you please break down this constructor for me and explain it? 5 years old. Absolutely. Let's measure making a real-life painting canvas. This is like saying I want to make a canvas that is this wide and this tall. You're telling the canvas how big it should be. This is like taking the measurements you were given, making sure that's now imagine a spot on the canvas to be one of many colors. Oh, okay. Whoops. Whoops, maybe explain it to someone who's familiar with C++ but forgot a lot of stuff, like constructors, default. Sure, let's break it down. There we go. This is a constructor special function. Usually sets up the initial state of the object. This is the constructor declaration. That's what this is what I want. It says the constructor takes two parameters, width and height. This is the initializer list. It's a comma separated list of initializations for member variables. Comma separated list of initializations for member variables. Each initialization has the form variable value. It sets the member variable to the value. And data when it does that is hope this helps. Perfect. Okay, so data when it does that width height times 3. Okay. Which is that. Oh, I gotcha. Okay, so you can actually do that right here in the constructor. Colon with the initializer list. It's a comma separated list of initializations for member variables. Okay. Yeah, and you can have different constructors too. Yes, that's correct. You can choose to initialize as many or as few member variables as you need in the initializer list of a constructor. If you don't include a member variable in the initializer list, it will be default initialized for basic types like interchart. Oh. This means they won't be initialized at all. Contain values previously in memory. For classes, their default constructor will be called. However, it's generally good practice to initialize all member variables to prevent any unexpected reasons, especially important for remote types in a chart, which don't be right. Okay, cool. That's good to know. This is what I've already been doing, but I just want to read it. Yes. A class can have multiple constructors, each with a different number of parameters. This is known as constructor overloading. Each constructor can initialize a different set of variables. Member variables, right. Default constructor with one parameter, int a, xa, y0. Constructor with two parameters, int a, b, xa, yb. Okay. Oh, and that initializes them right there. Okay. This allows for a lot of flexibility when creating objects. You can choose the constructor that best fits your needs. Okay, that's perfect. perfect. Thank you so much. So funny. I talk to it and I'm polite, alright? So fight me. Fight me. Alright, so inth, width, height. So this one takes the width and height. Okay. I guess what threw me off on that was 2 parameters for initializing the canvas class and 3 initializer see if it remembers that. I see where the confusion might come from. Let's break it down. In the constructor canvas width height, there are indeed 2 parameters and 3 initializations in the initializer list. Here's what's happening. The constructor takes 2 parameters, width and height. These are the values you provide when you create a new canvas object. Initializations. This sets the class member variable. Okay, this creates an XT vector char name data with the size of width. The width and height used here are the values of the parameters you passed in. So even though there are only 2 parameters, they are used to initialize 3 member variables. The data member variable size is dependent on both width and height, hence why it might seem like there's an extra initialization. That's perfect too. I just wanted that to be spelled out because that's what's happening here. So this gets set to the width, this gets set to the height, and then this is already in the initialization using the width and height in the initialization of that. I just wanted to spell that out to myself. And AI gladly complies, which is awesome. Alright, so that's really good. Now that we've spent so much time on something I said I would do quickly, let's move on. Creating a canvas, writing pixels to the canvas, right? Okay. Bum, 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 ba-da-bum. So let's go like this. Don't we just put it right in here? I think we just put it right in here. Go like this. Right pixel. So what it's going to take is an int x, int y. We already have a reference to the canvas, and then we just need a color, so it's going to be, what, a glmvec3 color? Or is it going to be a tuple? It's just going to be a color, so glmvec3, and we'll just send in a glmvec3, I believe. Is it not able to initialize that? Like this right here, is that not the way to... Boom, 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 boom. Explicit type is oh, okay. Right pixel. We're not returning anything, so there. There we go. So canvas, so data. So data sub the width, which is going to be x, plus y times the width. Okay. And each one of these is going to be times 3. So all of that, right, times 3. And then what we're going to do at that point is, just to be clear, we're going to go plus 0 equals, and this doesn't have a name, color. Okay, so that should effectively do that. We're good. because each pixel is RGB, right? So as we're going through, and let's just run this through OpenAI. Am I off by like 1 or something? We'll see. No, it's breaking it down for me. I like that. This calculates the starting index in the data area for things. Because the user used to access the regular blue respectively. Yeah, there are a few things you might want to consider. Bounds checking. You might want to... Oh, that's a good idea. You might want to add some error checking to make sure that X, Y are within the bounds of the canvas. If X or Y are out of bounds, accessing that could lead to... Oh, it definitely will. Remember, these are just suggestions. What was the other one? Depending on how you're using the data area, you might need to ensure that the color components are in the correct range. If data is being used to store color data in the range 0 to 255, you'll need to convert from the range used by glvec3 to that. Here's how you might modify your function to include this consideration. Okay, we'll do that later, because it explicitly says in the book we're going to do that later, because when you're doing lighting calculations, sometimes it goes below 0 and above 1, but you want to preserve that for the sake of the calculations, and then clip it later. But let's keep this. Let's do this. This is really, really what I need. Right pixel. There. Then I need a return here, right? Okay. Okay, does that compile and run? Well, I'm not doing anything, but we're just going to compile it there. Okay, so that compiles. What's the test here? Okay, and then saving the canvas now. So we already have the canvas as our vector. Okay, let's do this really quickly. So we already have that, if data, okay. Okay. Sure, I can help you rewrite to use the SCD vector char data. Here's how you might modify your code. If not data empty, data.data, otherwise everything's the same. Cool. That's cool right there. Nice. That's so awesome. In this version of the code, I've replaced data with data.data the function call, because data is now an STD vector char, and data.data gives us a pointer to the first element of the vector, which we can use just like a C-style array. Also, I've replaced if data with if not data empty. This is because data is now a vector, and data empty will return true if the vector is empty and false otherwise. So if not data empty, we'll check if the vector is not empty. Oh, okay. Finally, I've removed free data. This line is because data is now a vector and its memory will automatically deallocate and goes out of scope. No need to manually free the memory. Thank you, thank you. Okay. So let's put that in the code. If not data empty, I can do that. Boom, boom, boom. Okay, but we're going to do that in a new function, right pixel. Okay, now we're going to save canvas. So we're just going to go void save canvas. We're not going to worry about the file name or anything. We're just going to save the canvas. And when we do that, just going to use this exact code right there. So if not data empty, GL pixel store there, read pixels. Wait, what? These specify the window coordinates of the first pixel is read from the frame buffer. This is the lower left corner. The dimensions, oh, so we want 0 and 0, and then width and height, okay, is going to be. So here we want 0 and 0, and then width and height is going to be the width and height of the thing. GLRGB is 3, and GL, okay, I've just never dug deeply into that. Okay. File name, counter. Okay, this is... It's an include, I forgot. It's one of the includes. I think it's this one, dir ENT. I don't know. I don't know, I think it's this one. Whoa, that's cool. Oh, do I have that? That's actually another function. We have this as another function. I forgot. Hold on. Stand by. Please stand by. I think we just need to put that in here. Let me just grab it, because we... Yeah, dir int, and it does that. Okay. If you're trying to count the number of files in a directory, you can use std file system, which is available. So file system, count files in dir, std distance, fs directory iterator path, fs directory iterator. This function counts the number of entries in the directory specified by path. Note that includes both files. You want to count only files you can find. Okay, hold on. So what does this one do? Path. Oh. Same thing. This one seems like, okay, let's just... Let's see. Okay. Okay, so let's use that function. We need to include file system, and then namespace fs. We can just, okay, hold on. See what it says to that one. Sure. Oh, there we go. Okay. File system, C, math, string, and vector. Okay. String, okay, yeah. We already have vector. And that's a private function, that's fine. So let's go down to canvas, private. Goes after the data, okay. FS, yeah, and it uses the namespace there, so. How does it? Namespace fs equals std file system. There we go. Now this one, okay, and then we're going to rewrite that. Save canvas. Okay, so let's just... Oh, but I left out this. Okay. Because I only copied that portion for the AI, so it didn't do this. But we need to. We need to do this. So let's... See, no, that was cool. Visual Studio did that. That was cool. Save canvas. Right pixel. Okay. Right, and that's fine. That's fine. Okay. Okay. What else? Did you say anything else? In this version of the code, I've added the count files endure function as a private member function of the canvas class. Count files endure const fs path return std distance directory iterator. Okay. File name count files endure path. So save canvas and then path. Okay, and when I use this here, count dir path. So where did we use this? Oh, where did I use it? Is it in main includes? It's got to be in that take screenshot then. Counter right there. Oh. That's the parameter. Okay, hold on. So here. We're just going to hard code that in there. Then we don't need a path. We could hard code it in here, I guess, even further, but I think we're fine there. So, okay, that took a while, but so writing pixels to a canvas. Okay, and it goes into doing a ppm file. We're not going to do that because we already have the means to save as a PNG with a stb write PNG. Construct the header, constructing the pixel data, putting it together. Okay, so it wants me to do this, which was an exercise. Splitting long lines in ppm files. Every pixel of C is set to color that. Okay, so this is the last exercise. Basically do some drawing on the canvas and then save it to a file. So let's do this. First of all, in addition to this, so that would just be, or can I put that in the constructor? Oh, perfect. You can do this directly in the constructor. Here's how you might. Okay, that's what I want. Initialize data to black. Data with height 0. Oh, you just have to put that like that? Oh. That's cool. I didn't know you could do that. So right here, comma 0. So that just changes it all to 0 right there. Boom. That was easy. In this version of the constructor, data width times height times 3 comma 0 creates an xd vector chart with a size width height times 3. Initialize all elements to 0, which represents black. Right, I got you. Okay, this clear function uses a fill. If you want to reset the canvas to black at any point, not just at an initialization, you can create a member function to do that. Clear std fill. Fill data with zeros. This clear function uses the std fill function to set all elements of data to 0. Oh, that's handy. Let's do that. Can I just... Okay, copy paste. Let's just copy it from here. That's fine. We're going to do that. Right pixel, save canvas. Just going to go clear canvas. Hold on, my neighbor's doing some work. I'm going to close the door. Okay, I realize I still have to do some laundry and some shopping, make some soup. So that's cool. Okay, so let's test the canvas here. I haven't even done anything with the canvas. We've got all this functionality. So let's go down to main. Get rid of all this stuff here. Okay. So the first thing we want is a canvas. We'll call it test. We'll make it, let's go binary, 256, 256. Does that do an initialization, or what does that do? I even forget now. Width and height, okay, sets it all to 0, clears it out, okay. So now let's just do something real simple. Down the center of the canvas, let's go for glue int I equals 0. I is less than 255, or 256, yeah, I plus plus. So let's call the test right pixel. And we're just going to write to the x line 100. And the y is going to be I. And then the color is going to be a GLM vec3. And let's make it red. So red, green, and blue. Like that. So we will write 256 pixels straight down, not the middle, but actually if we want in the middle, we can, yep. We can go in the middle at 127 there. And then we want to test dot save canvas like that. Okay, it doesn't, I don't think it does anything here when it saves, does it? Saving screenshot. And it lists the file name. Okay, so let's see what happens. Nothing. Oh, and it's exited. Did it crash? It looks like it crashed. Looks like it crashed. Okay. So, what happened? Did we get an initialization here? What? Computer what? I don't know why there's red squigglies there. We might have to reboot. Oh. Wait, what did I... Now what did I do? Yeah, it's bugged. I don't think we'll have to necessarily reboot. Let's close this down. Close down as much as possible. Let's close down Twitch Stream Manager just to... If it comes back up, I think it's gonna be good. Okay, there's still an error, but what is it? Oh, I forgot the parentheses there, or the quotes there. Or I deleted it. Okay, sorry computer. Maybe I didn't need to do that, I'm just losing my brain. It's all good. Okay, step 1 and 2, and then the save canvas is what broke it. Okay, so save canvas is breaking it. Let's go break that down. So if not data empty, let's just put some steps in here. Step 3. It's just pretty sure this is not the problem. Pretty sure it's this last one right here. Step 5. And then right after that. Step 6. Let's see how far it gets. I'm willing to bet we're going to see all the way up to step 5. And then it'll crash. Oh no, step 3. Okay, so step 3, and then this doesn't work, or this. Read pixels. Is it width -1? Is that the problem? Oh, and then it say, hold on. Nope, that's not the problem. I don't know that it is read pixels. It could be count files in dir. So it is read pixels. Wait, make sure you have a valid OpenGL context and it's correct. Oh, I haven't initialized OpenGL yet. Okay. Thank you. That makes sense. We haven't initialized OpenGL. We haven't done anything with OpenGL. So let's, oh shoot. We can just borrow the, this. Class system space gems 114. Basic OpenGL window. I don't think we really need the window, but let's initialize it here. What's the, oops, hold on, what's the, there it is, system 1. Okay, so let's initialize that. System 1. And we want OpenGL. And then we go OpenGL init. Hold on. Space Gems 1 init. Okay. I think that's all we have to do. Oh, I don't have all those either. Shoot. Well, we can just cut this back. Hold on. Maybe we could get a different... Hold on. Class system. 3D terrain one. Is that a quicker one? Space station generator. Is this a simpler one? They're not very simple when they use all these. Here, we can use this one. But let's change it. Let's just call system ray tracer. There. Hold on. Class system ray tracer 01. Gotcha. System 1 is what it's still called. Okay. This one though, we want to take out this frame buffer, key callback, mouse callback, scroll back, all this stuff. We don't want any of that yet. When we get it, we can just copy it from whatever, create window, make context. We don't need all this. There. Seems legit. And then down here when we initialize, OpenGL init, and at the end we're just going to go OpenGL cleanup. And when we declare this std, okay, so we need to do this after these includes, is why it's saying std, all this other fun stuff. And now it works. Okay, so let's look at that screenshot real quick. The file 5b0. What? That should be interesting. We just go date modify this one. Oh, I don't see the line though. Did we not get a line? We didn't get a line anywhere. But it is a blank thing. So did we not write the pixels or what happened? 5b0? What's the what's the 5b0? We're not going to worry about that just yet. Oh, it didn't write it because of this is a right, hold on. Char color R times 255. So it did actually do it, but it didn't do it because of this. Alright, green and blue. Alright, let's try it again. Wonder what it's gonna do. 5B1, okay. And it did a little flash on the screen, that was weird, okay. Oh, we have one pixel. We have one. We have one pixel. Actually, it looks like more than one. What is going on? So right pixel 127, comma I, 0. Width times height times 3. So width times height. Am I doing this wrong? I just want to know why it wasn't all the way up. Like it did write some of the pixels, but 0 to 256. Let's do a diagonal line. At least I got red on there, though. 52B. Oh, now it's way over here. Okay, so there's something wrong with the allocation of the memory or the right pixel function. So what's it doing? It looks like it's starting there and writing like that. Did we get any errors? Oh wait, did it go out of bounds? Did it say here? Oh, I just hit Control F5 in the File Explorer. Okay, so it doesn't have any errors of out of bounds or anything. It saves the screenshot, everything's fine. But we're getting, it looks like, it's either not doing anything, and then it's just doing the last two for some reason. Weird. So I'm wondering why. Right pixel, I, there. Okay. XY data. Let's try the same thing, but we'll go with more. Because I'm not sure what's happening, but we'll see. We're going to see. We're going to find out. Okay, now there's nothing. There's no red. So I think there's something wrong then with the right pixel function here. Either that or there's something wrong with the save canvas here, which I don't think there is, because it's... This was never the problem. I don't think that's it, though. No. Okay, so let's try something else. Let's go right in the middle here and go for GLU J equals 0. J less than 50. J plus plus. So we're going to make the whole chunk, a whole chunk of it, 50 by 50. And now we get nothing. Wait. Is there nothing? Huh. Okay, so I'm not sure what's going on, guys. I really don't know. Alright, alright. Well, for now, that's good. We're going to call that somewhat progress, although we've reached an issue, but we'll see what's wrong with the canvas later. I gotta go get something to eat, clean up, and do all kind of stuff, get ready. Thanks for tuning in, whoever's here. I don't even know. Oh, that's right, I switched it. Okay, not enough to do a raid, we're good. Alright, everybody have a great day.